Okay, so we are unmuted, right? We are unmuted. So in the last class, I think we started work and energy, right? So what did we do in the last class? Let's quickly review. So first we defined what is work, right? Which is force times displacement. Then we differentiated or learned about different types of work. So we had no work and positive work and negative work. Yeah. Yeah, okay. So no work, positive and negative work. When do we say there is no work? When the applied force causes no displacement, right? For example, pushing the wall, right? So I can say F into 0. That's when no work. Positive work when force and displacement are in the same direction, right? That's when the work is positive. And negative when force is in opposite direction and displacement is force and displacement are in opposite direction. Could be force in this and displacement in this direction. Okay, any which ways, right? So it will be minus F into S, or if it was force in this direction and displacement in this direction, then it will be this is plus F minus this is plus S minus F. Sorry, this is plus and this is minus. Okay, that's fine. Right to left is minus. Okay. So these are the examples of no work, positive work, and negative work. Third, we also defined energy. What is energy? Yes, capacity or ability to do work is energy. Right? Then we did types of energy. Okay. So what are the main types of energy? Yeah. So there are basically 6 or 7, right? 7. Including nuclear energy, it is 7. Right? In this chapter, we are going to discuss about mechanical energy. Okay? So what are the 2 types of mechanical energy? So we have kinetic and potential energy, right? So we discussed about kinetic energy. What is kinetic energy? So any moving body would have kinetic energy. Any body which is in motion will have kinetic energy. Right? So what is the expression for kinetic energy? Is how much? Yeah. Okay. Now, how did we derive this expression? Whenever we work on a body so that it reaches this velocity, right? That work appears as energy, right? So we must have derived this formula. Yes. Half mv square minus half mu square. Did we derive this formula? We have derived, right? What now? We derived this formula. So this is 1 by, so this is basically delta K, right? So this is what? Did we not derive this formula? So we derived, right? So whenever we do work on a body, let us say body was initially at rest, say U equal to 0. Now when a force is applied, it travels some distance or displacement S, right? and here it is moving with velocity e, because when you apply a force, it will be accelerated. So therefore, its velocity will change from u to e. Okay. When you substitute u equal to 0, you'll get this is any body which is moving with velocity v will have energy half mv square. We derived it, right? We derived it. So how we get this energy? I told you, whenever you work on a body, body gains energy. So always remember this, right? So when work is done on a body, like here, when you are pushing the body, and then this body is undergoes displacement. So work is being done on the body. That work appears as energy on a body, then it gains energy. Right? So work gets converted into energy. And the other thing is, whenever the body has energy, it has tendency to do work. So work and energy are interrelated. Okay? That's why both their units are. What is the unit of work? Newton meter, which is joule. What is the unit of energy? Joule. Okay? So their SI unit is joule. Okay? So when work is done on a body, it gains energy. If work is done by the body, it will lose energy. So if you are studying continuously, you will need to eat after some time, right? For any body which is running, it can't run forever. It will run out of petrol. So फिर से petrol डालना पड़ेगा. Got it? So these are the important concepts. When work is done by the body, it loses energy. So those who were absent in the last class can write the full thing, and those who were present in the last class can write only these 2 words. So this is a summary of what we have done so far. This also I discussed in the last class, right? Have you noted it? If you have noted, then note. So today we'll be starting with concept of potential energy. Right. Did we do numericals in the last class? So we'll do some more numericals on kinetic energy before going for potential. I think I only derived the expression for kinetic energy and then I stopped, right? So do we have any online student? Is there any online? Okay. Quite a few. Okay. Let's begin with numerical 11.3. This is from NCRT, page number 151. Okay. So read the numerical. What does it say? An object of mass 15 kg is moving with a uniform velocity of 4 meters per second. So what is given? Mass is given. M is equal to 15 kg and V is equal to 4 meters per second. What is the kinetic energy? So you have to find out Ek is equal to what? So this is half mv square, right? So what will be solutions? Solution is Ek is equal to half mv square. So this is straightforward, right? This is half into 15 into 4 into 4. Right? So it will be 60. Okay. So therefore Ek is equal to 1 by 2 into 15 into 4 into 4. Also 4 2s are. So it is 120, right? 120. 15 2s are 30, 3 4s are 12, 120. Okay. So numericals are very simple if you know which formula to choose. Let's do next numerical. So in this numerical, you have to find what is the work done. So initial velocity u is given as 30 km per hour. Final velocity is 60 km per hour. Okay, mass is given as 1500 kg. Right? So what is given is solution. So you have a car, right? So there is a car. So initially it is moving with velocity 30 km per hour. Right? Now the force is applied on the car. So the new speed it gains is, so there will be force due to which it will gain acceleration. And its new speed is 60. Right? So its speed has increased. That means force is acting on the car or acceleration is acting on it. So some force must have worked on it. Right? So what is the formula? What is the formula? Work done is equal to half. Whatever is the work done, it will be equal to difference in the kinetic energies. This is what we learned, right? So you have to find what is the work done. So it is nothing but difference in the kinetic energy. So this is, you can write 1 by 2 m v square minus u square. So just substitute the values. But now here the velocities are given in kilometer per hour. So to convert into meter per second. So into 5 by 18 meter per second, right? So what is it? 6 3s are 18, 6 5s are 30, 25 by 3. 25 by 3 meters. What about this? This is 60 into 5 by 18. So 10 times 3 times. This is 50 by 3. Keep it in fraction. Okay. So therefore, this will be half m is 1500. So if it is like this, okay, you say v plus u, v minus u, right? Then the calculation will be simple. Can you do it like this? So this is therefore W is equal to 1 by 2, 1500 What is V? 50 by 3 plus 25 by 3 and 50 by 3 minus 25. 22 into 1500. So this is 75 by 3. This will be 25 by 3. So now you can cut it. So this will be 25. So 1 by 2 into 1500. So this is 625 by 3. 25 square is 625 by 3. And this is 2 sevens are 14. So 750 into 625 by 3. So this will cut 3 to the 6. Will it cut by 3? No. 6 to 8 plus 5. This will cut 25, right? 25 to 20. So how much is this? 250 into 625. Just find this out. So 250 to 625. Yes, 15625. Is this the answer? Okay. So wherever you have mixture of SI unit and some other unit, you convert all the given data into SI unit and then do the calculation. Okay. So now you should be able to answer these questions on page 152 in text question. What is the kinetic energy of an object? You're writing students. Are you done writing, all of you? Let's discuss the in-text question on page 152. So there is a hands who will answer, right? Even online students can answer. So unmute your video, online students. Keep your videos on. So we are going to discuss question on 152, right? So what is kinetic energy of an object? Raise your hands, who will answer? Only one hand. Online students, would you like to answer? What is kinetic energy?
The energy possessed by an object due to the
Motion. Yes, very good. Or energy possessed by a moving object. As simple as that. Okay, it's called kinetic energy. Write an expression for kinetic energy of an object. Boys, what is the expression for kinetic energy of an object? It's written on the board. Yes. Yes. Half into mass into square of velocity. Then there is a numerical quantity. So the kinetic energy of an object of mass m moving with a velocity 5 meter per second is 25 joule. What will be its kinetic energy when its velocity is doubled? Then the second question is, what will be its kinetic energy when its velocity is increased 3 times, right? Can I erase this? We have in text question 3, page number 152. So what is given?
Kinetic energy.
So EK is given as 25 joule. What else is given?
Velocity of 5 meters.
Velocity of 5 meters per second. 5 meters per second. Okay. So EK is equal to what? If V dash is okay, let's call it U. V is equal to 2U, right? And EK is equal to what? If V is equal to 3U. This is what is asked. Okay. So let us see. So since so what is EK? EK is equal to half mu square. Right? What is EK? Half v square. So let's call EK dash E double dash. These are the new energies, right? So EK is the original kinetic energy with U. Okay. What was U? 5 meters per second. And this is equal to how much? 25 joule. So therefore EK dash is how much? EK dash is equal to 1 by m 2U square. This is equal to 4 times 1 by 2 mv square. Right?
So sir, can we do this? That means first we are having kinetic energy and the velocity of the object. So from that we will find the mass.
You can do that way also. But here I already know the energy, so it becomes 4 times. In the next case, it will become 9 times. Okay? So 425 is 100. Right? So you can do that way also, but I would suggest you do this way. It will be easy. This will be how much? 1 by 2 m. So this is like 4 times EK. 4 times EK, right? EK. 4 times EK. Isn't it? Because what is EK? Half mv square. And 2U is 4U square. So 4 को बाहर ले लिया. यहाँ पे क्या हो जाएगा? 3U square. So this will be 9 times mv square, which is 9 times EK, which is 9 into 25. When the velocity is doubled, the energy will be 4 times, ना? Because velocity is doubled is U का 2U हो गया, तो उसका square 4U हो जाएगा ना? 2U square, 2U whole square. ये पूरा, so it will be 4U square, right? So the energy will increase by 4 times. When the velocity is tripled, energy will increase by 9 times. Okay, it will not be 3 times. So 9 into 25 is 220. Correct? Check what you did this. What is that? What is the difficulty? Five का double is not 25. 5 का double is 10. 5 times velocity करके उसी double कर. Okay. So 100 joule and 225 joule. So when the velocity is doubled, energy is quadrupled. And when the velocity is tripled, energy is 9 times. Okay. Because energy is proportional to square of velocity. There is no direct relation. It's proportional to square of velocity. All right. So now we'll start potential energy. So what is the symbol? EP. Okay. So now mechanical energy has two components. One is kinetic energy, the other is potential energy. Kinetic energy will come later. Okay. So now let us see what is potential energy. It is the energy purchased by a body purchased by this device. What is the spelling? Possessed.
POSS. Double S.
Again double S.
Yes.
Again double S. Possessed. Okay. It is the energy possessed by a body by virtue of its position or configuration. Okay, I'll explain what does it mean. So, right. Does this body has any energy right now? This bottle. First, you write the definition, then I'll explain. So somebody said change of shape, right? Configuration, there is change of shape. It means okay. Change of configuration is actually change of shape. Right? So let's see both type of example. Explain. Suppose there is a body which is kept on ground. This is ground. Ground is earth. So it has no energy because it is stationary, right? It is not moving. Now what we are doing is we are raising it to a height h. This body is raised to a height h. So body's position, let's say this position we called as A, and this position we are calling as B, can be changed from position to position B. Right? Body's position can be changed from position A to position B by lifting it line by lifting it from to position. Okay. So when you're lifting, what are you doing? You're applying force, right? So therefore, work done during lifting the body against gravity, right? When we are lifting the body, right, is some force acting on it. What is the force acting downwards? It's weight. Okay. Also gravitational force. That is Gmm by r square. But what is its weight? Mg. So its weight is acting downward. So when you have to lift it up, you have to at least apply or overcome its weight. So you have to at least apply force in the opposite direction, which is equal to its weight. Got it? So when you lift it with the force mg, then you can move up. Got it? So work done during lifting the body against gravity. Now we are doing the work. The same work will appear in the body as its potential energy. Right? Work done during lifting the body against gravity is stored in the body as its gravitational potential energy. Okay, so whatever work is done, that is stored as its gravitational potential energy. Right? So therefore, what is gravitational potential energy? Potential energy EP is equal to work done in lifting the body from A to E. So how much it will be? It will be force into H. What is the force? Mg, right? Force acting is W is equal to Mg. So this must be equal to Mg H. This work done itself is energy. Okay. So have we changed the velocity in this case? What was its initial velocity? At A, 0. What is its final velocity at B? 0. So is the velocity changing? So is there any kinetic energy? No. So when you apply force on a body, right? And that force will do some work on the body. But in that work, velocity is not changing. That's during such kind of work, its potential energy will increase. Whenever you work in a body, when its velocity is not changing, that time its potential energy will increase. Got it? So that's what it is. So, or whenever work is done against any force like gravity, or if there is a spring or elastic, when you stretch a rubber band, okay, you are working against the restoring force in the rubber band, right? Because when you release it, it will restore its shape. Such objects are called elastic objects. So spring, right, or any rubber band, whenever you stretch it, like in your book, the example is given of bow. So when you place the arrow and then you stretch the string, then there is potential energy in the string, and when you release it, that time that potential energy will get converted into kinetic energy of the arrow. Okay, bow is तीर नहीं कमान, right? तीर कमान, तीर is arrow, kaman is bow, right? So this is your gravitational potential energy. So for you only gravitational potential energy you have to learn. There is another example. So that was the example of due to change of position from A to B. Now what is change of configuration? Change of configuration example. Suppose you have a right. Let's say this is the right now the string is not stretched. Now when the string is stretched, right? So stretched string is the shape changed? Initially it was linear, I mean straight line. Now it is stretched. So the shape is changed or its configuration changed, right? So change of configuration. This is change of configuration. Okay. So the stretched string has elastic potential energy. Right now it has no potential energy, but when you worked on it, you did work, it has no velocity right now. Finally also it has no velocity, right? But now when you release, that is when all the potential energy will get converted into kinetic energy of the arrow. So now, and any body which has energy will have ability to do work. So when you leave it, and its energy will convert into work of the arrow because it is now moving. It will push, right? Like if I throw a stone on this window, it will break the glass. So the stone had kinetic energy. That's why it applied force. So any body which has energy, how does it work? By applying the force on the body in which it comes in contact with, right? See. What happened? So whichever body has energy, when it comes in contact with other body, it will start working on it by applying force. Got it? That's what. And in the process, it was moving, so it had energy. Now it stopped and it got pushed. Okay, it's like this. So it lost energy, it gained energy. Okay? So energy is never created nor destroyed. It just gets converted from one form to other. So we'll see that. So who lost energy in the end? Right? This did not have energy. Who supplied energy? Me. So I lost energy. Right? So it's only me who is losing energy. Everybody else is gaining energy. Okay? All right. Are you all with me, online students? Okay. Any question, feel free to ask. Okay. And don't hide behind the video. I can see Aryan. Aryan, put your
Yes,
video.
sir.
Put your video on.
Sir, I recently had a surgery, so I can't sit.
Okay, okay, okay. It's okay.
One day I switched on my camera, but after that I had a back pain, so doctor suggested not to sit for too long.
All right, all right. Okay, carry on. But you can still ask me doubt. Are you able to listen and see the lecture?
Yes,
Are
sir.
all right, all right. Okay. So anybody has any doubt in potential energy? Yeah. So there are two types of potential energy. One is gravitational potential energy, because now we are working against force of gravity, right? Other is change of configuration. Example, what is the type of potential energy over here? It's called elastic potential energy, and we will not be discussing elastic potential energy. Okay, whenever there is a change of shape, the potential energy is elastic potential energy. But we will be taking questions on gravitational potential energy only. Okay. Now take time to read the activities. Is it time? Okay. So homework. Go through activity 11.8 to 11.11. This is all about potential energy. So homework. Okay. You should be able to understand it. It's very simple, right? If you have any difficulty, ask me the next. Okay, see you in the next class.
Where right angles, and then right angles, another point one hand triangles.